Welcome everyone. My name is Lloyd and I'll be your moderator during this session. I'll be monitoring the Q&A and the chat box, so feel free to ask any questions during or after this presentation. This is a live presentation, and after the presentation, Vivian will answer questions posted in the Q&A. Over to you, Vivian.
Thanks, Lloyd. So I'll go ahead and start sharing my screen. Great, can everybody see that? Or Lloyd, I guess, just give me a great confirmation. Awesome. So hi, everybody. Welcome to FHIR Analytics using the OHDSI tool suite on cloud. I'll be talking a little bit today about how we see common use cases being used in the OMOP common data model from FHIR in order to enable the OHDSI tool suite. And for those who are not familiar with that, I will also do a little bit of a dive into what the OHDSI tool suite entails. So first about me, Vivian Neilley, I'm a solutions consultant at Google Cloud. I've been in this role for about 3 years now, so I work primarily with our healthcare products. Those of you might have joined our other sessions on our healthcare API or some of our transformation to FHIR logic that we're working on in the open source community. So I spend most of my time and day thinking about those. Again, I'm really going to talk about the open source reference implementation that we have published that converts the FHIR format into the OMOP CDM common data model, as well as how to use the OHDSI tool suite over the Google BigQuery, which is really our data warehouse product within Google Cloud. I will say I'm not going to go too much into pain points of mapping OMOP to FHIR. There was actually a fabulous FHIR DevDays presentation in 2019 done already on some of the pain points that you're going to run into if you are deciding to map your data from FHIR into OMOP. And so I suggest everybody, if they're interested in the pain points or the technical implementation of some of those more specific mappings, definitely go check out the presentation. It's live on YouTube, actually. So first and foremost, just a quick overview on OHDSI. For those who are not aware of the program, OHDSI is the Observational Health Data Sciences and Informatics program. It really came out of Columbia University and is still housed there, but it's become this international network. We commonly see it used within the pharma space, so a lot of pharmaceutical companies are using it, as well as academia. The OHDSI program, really, they publish and manage all the tools that a lot of public open source researchers are familiar with. So if you've ever heard of Atlas or Achilles, as well as the Athena standard for vocabularies, those are all managed by the OHDSI community and the OHDSI program. All of their tools and tool suite are underpinned with the OMOP common data model. For those who are not familiar on kind of why someone would be interested in OMOP and why I'm talking about OMOP at a FHIR conference, we see FHIR often as an intermediary into OMOP. So there's a lot of conversions and a lot of ways to get data out of an EHR into FHIR, and a lot of, as I said, pharmaceutical companies or academia space researchers are looking to convert that into OMOP. And the reason for is OMOP is a flattened data model. So unlike FHIR, it can be a little bit easier to manage. It also does things that can be nice for research. So for example, it will break out lab values from observational data. So as we all know, lab values are in the observation resource within FHIR. And those are actually two separate tables within the OMOP CDM. And so this can be a little bit helpful in terms of navigating the common data model, as well as just working with other open source communities outside of the FHIR community. And so Google Cloud has actually, for those who have joined some of our other talks this week, we have actually worked on a transformation architecture. So what this is, we named it WHISTLE. It really is a configuration-driven approach where we encode the logic in this compact mapping syntax. And so the execution of this FHIR to OMOP, for example, can be fully managed on the cloud and actually, or by the open source community. So instead of managing these custom pipelines, you actually can utilize this out-of-the-box pipeline that we have open sourced. So you won't have to worry about necessarily the code or managing and updating the pipeline that's going to be running your transformations. And while I'm currently talking about FHIR to OMOP, the transformation library is actually intended for any arbitrary JSON to any arbitrary JSON. And so we actually have a lot of different open source mapping configurations for other data models as well, such as HL7, CDA, FHIR, for example. And we've published all of those on Git. So for anyone who's interested in that, feel free to ping me after and let me know, and I'm happy to send those resources over. So here's an example of the resources that actually have been converted to OMOP tables. So this is a patient resource being converted to a person table. And you can see why this may be a nice alternative to something like a custom pipeline, where you're only managing a small, compact amount of configuration-based language rather than a fully custom, for example, Python-based pipeline. And so we kind of take the management, or we attempt to take the management out a lot of the custom pipelines by, one, open sourcing a reference pipeline, two, open sourcing reference configurations, such as the ones that we've actually done for FHIR to OMOP, as well as managing the whole mapping engine. And so once the data is in OMOP, and this is one way, the open source Google published way, which is really this transformation engine I've been talking about, is only one of the ways to get data into OMOP. There's a lot of partners who we work with and out on the market who will also work to convert your data into OMOP. Georgia Tech actually is the one that we've used as a reference mapping. So they've published a whole STU3 to FHIR configure or mapping syntax, and so that can be another way if you're kind of looking to create that custom code yourself. And so once the FHIR data is in OMOP, a lot of people say, what is that useful for, and what are these tools? And so what Google Cloud has done is we've actually spun up all the Odyssey tools managed on Google Cloud, underpinned by our data warehouse. For those who are not familiar with BigQuery, this is our managed, you talk at it with the SQL dialect. However, it's actually structured in a NoSQL horizontal database. And so we've seen it scale to petabytes. It's extremely fast. It's extremely cheap. It's an awesome way to manage, to have underlying data underpinning some of these applications, for example, like Atlas. And actually, in this case, we worked with Odysseus Data Services. They're one of the partners, and they're an organization who also works with customers to map their data to OMOP if customers are not interested in doing that themselves. Odysseus Data Services also maintains a lot of the common data models and like open source profiling and terminology, and helps update the Atlas tools on a lot of cloud platforms beyond just the Google Cloud platform. So if you're interested in using a managed instance of Atlas, a lot of the time Odysseus Data Services has managed instances of this tool across different platform providers. And this is also available on GitHub if you're not looking for a managed service, you're perhaps just looking for an open source implementation. All of Odysseus's tools, or Odyssey tool suite, is available on the open source community. And so what can you do with these tool suites? Atlas specifically is really a patient level cohort tool. And so again, since it's underpinned by the OMOP common data model, it gives this awesome UI for researchers to define cohorts. They can profile their data. There's different analytical methods that they can kind of implement from a UI off of the data. And this is a great way to not only share cohorts with other research institutes, but also kind of manage, profile, understand your data in a open source application way. And so we see this being used in commercial organizations. We see this, again, a lot in academia, but it can be also useful just to kind of play around or interested in sharing your data. This is a example of profiling data within a cohort. And you can see this is actually using the standard OHDSI Atlas directly within Google Cloud. So here's just a tree map where we can see we're pulling different profiles, and you could click into any of these boxes, and it really allows for a better or a good view of profiling a different cohort depending on what you're looking for out of the data. Another great thing about Atlas and OMOP as a whole is there's a lot of standard vocabulary and terminology mappings. And so that can be a little bit of a challenge when working with something like a FHIR data model if you're mapping from multiple sources. And so OMOP and a lot of the mapping does a great job of keeping together their vocabulary and terminology, as well as those concept maps. And so right at 11 minutes, which is hopefully where I was supposed to be, this was a really quick overview on just why some researchers choose to use the OMOP Common Data Model as well as the OHDSI tool suite. I'm happy to talk more with anyone who is interested in this, as well as here's my contact information. Feel free to follow or go ahead and give me a shout out. So I'll go ahead and take questions. I'm not currently in the Whova app, so I believe they may or may not be read to me, hopefully.
Oh, thank you, Vivian. Yeah, let's proceed to the Q&A then. Okay, first question. Many times the flattening required to move information from FHIR to OMOP requires local contextual knowledge. For example, which coding or identifier should be exposed when there are many to choose from? Mm-hmm. How do you handle that in a generic way?
Yeah, so there's a couple of different mappings. When I think about how we talk about common data model mappings, there's multiple different things that you have to do. So you have to map the structural mapping, which is actually what I talked about today. That does not mean that users are off the hook for managing their units alignment. So you need your units to be harmonized. You need your terminology to be harmonized. Sometimes de-identification can happen during the mapping. There's a couple of different steps to mapping. What we've released is really just that structural mapping. And so there's still not a great answer for things like terminology conversions, or even, patient matching, for example, when doing data mapping. In the future, looking forward, as we continue to publish and work with the community to map between all of these healthcare data models, I suspect we're going to start seeing tools that will have smart mapping or recommendation services on which structure to choose, which terminology you're using, and which terminology you want to go to. I suspect in this particular case, the answer is we don't have a great answer for that. It's really custom person or implementation to implementation. I suspect in the future, we're going to see a lot of tools that have a little bit of AI built into it that are going to make smart recommendations for those use cases.
Okay, super, thanks. Yeah, we've got no other questions at the moment. Just let's have a look. No, nothing yet. Do you have anything to add to your session, Vivian?
No, I think that's all.
Cool, yeah. Okay, yeah. No, still no new questions arrived. Oh, yeah. Yeah, we have one thing. What kind of user-based community does this work have?
So I believe the question is actually talking about the open sourced mapping engine that I discussed early, not the Odyssey tool suite. So the open source mapping engine, since it's published by Google Cloud, most of our users are our large scale partners. So for example, our biggest implementation of this right now is at the Mayo Clinic, and that's also our most public. The great thing about open sourcing it is more and more when Google engineers, as they continue to publish out new mappings and reference architectures about this, our large-scale partners, such as the Mayo Clinic, will also continue to contribute to the open source. And so we hope, and the idea by open sourcing that is that our community grows. And there are other non-referenceable customers who are using this today. But it's, right now, I think the largest implementation of it is the Mayo Clinic, which is doing their HL7 to FHIR mappings using this mapping engine.
Okay. Super. Now let's have a look. No new questions arrived. Okay, we've still got another 4 minutes left in the session. So are there any questions from delegates who followed this session? I don't think if there are any questions left. Yeah, we might decide to wrap up the session at the moment. You fine with that, Vivian?
Yeah, thank you for having me, Lloyd, and thank you everyone for joining.
All right. Yeah. Thanks, Vivian, for your presentation. We hope that everyone found the session useful. And yeah, delegates, please do not forget to rate the presentation. And if you still have questions, please use the Q&A function. And yeah, Vivian will get back to you or answer your questions later on today or tomorrow. Thanks for attending, and goodbye to everyone.
Thank you.
Bye.